The system we're about to look at is actually the greatest advance in navigation since the 18th century, when an accurate way to determine longitude was developed. Not only is it simple, it allows you continuous knowledge of your position, something that would have turned Columbus, Magellan, and all those other intrepid mariners green with envy. We're talking about the Global Positioning System, or GPS, a Defense Department-funded constellation of 21 orbiting satellites and 3 orbital spares. They're nearly 11,000 nautical miles above the Earth and complete an orbit about every 12 hours. Because orbits like that are predictable, we always know where they are. Each satellite sends a message telling where it is and when it sent the message. A thousandth of a second later, it sends another message updating its position and the time. So, how does it work? Well, the GPS uses time to measure distance. Your GPS receiver notes the time it received the satellite signal. Since the satellite told the receiver when it sent the signal, the receiver's computer does a quick subtraction and figures out how long it took for the signal to arrive. So now the GPS's computer whips out its electronic E6B and says, let me see now. Radio waves travel at 186,300 miles per second, and that signal took 60 thousandths of a second to get here, so the satellite was 11,178 miles away. Just your basic plain old time speed distance problem. Your Skyhawk's GPS can do this with several satellites at the same time. If it can find out how far it is from any 4 satellites simultaneously, it knows where it, your Skyhawk, and you are. And in theory, that's all there is to it. Although there's a little glitch getting all those clocks ticking on the same time. Now, the clocks in the satellites are accurate to 1/1000th of a second. Clocks like that went for $100 grand a piece in 1986 dollars. So the one in your Skyhawk's GPS isn't quite that good. But your GPS's computer knows all those distances should end up in a single point. It performs some mathematical mumbo-jumbo, figures out what its clock's error must be, and everything is hunky-dory. And that's why there's a delay in getting information when you first fire up your GPS. But enough computer talk. Let's look at the goods. Okay, this is the little wonder right here. Now, as we touch on some of the GPS's capabilities, you may want to explore more of its features. That's okay, but the only place to study and become acquainted with the GPS is on the ground. When you're flying, you want to be head up looking for traffic, not head down trying to learn a detailed procedure. Before boarding our Get Acquainted tour, at the far left edge, notice a kind of slot with a little handle thingy at the upper end of it. That's the data card. No data card, no action. More about that later. The computer deep within your little black box can't do its job without a database. And like all other programs and operating systems out there, this one has many, many capabilities, many more than you actually need. But as you use them, you'll discover more and more useful features. Heck, just as with other computers, if you identify a task you need done, you can drag out the manual and teach yourself how. Later, you'll learn a couple of ways to back up navigation procedures that you've already learned in previous lessons. So, looking at the bottom of the panel, far left, is a switch labeled off-on. You can probably handle that without the manual. Then there are 7 white buttons across the bottom. Later on, we'll be using 3 of them, and we'll explain each one when we need it. Just above the buttons are 11 labels of 3 letters each. Some of the labels seem recognizable, like VOR, NDB, NAV, and SET. Others are a little more esoteric. You can think of each as being a chapter in a book, and each of the chapters may contain several pages. When we get over on the far right of the GPS head, we'll show you how to select a chapter or a page. The first 3 of those labels contain all 7 volumes of the airport facility directory and more. Yep, that's one of the reasons for the data card. Depending on whether a 28-day, 56-day, or quarterly replacement cycle has been chosen for your Skyhawk, your GPS could be more current than the printed version of the airport facility directory. We're not going to take advantage of all that information yet, but we'll cover some of the basic functions. Other functions you'll learn when you prepare for your instrument rating. Just browsing the manual will alert you to a wealth of possibilities. Moving over to the far right of the GPS, you'll see a double knob which works in conjunction with the cursor button here. If the cursor button is not activated, the outer knob selects the chapter and indicates the selection by displaying a little line over the specific chapter. The inner knob turns the pages in the selected chapter, and the page number and chapter identification are displayed here at the bottom of the narrow left panel. Now, if the cursor button is pushed in, the word cursor appears at the lower left of the screen, and the other knob moves the cursor around in the display screen. The cursor shows up as an underline, and the selected element flashes. Now, the cursor moves in the direction the knob is turned. Clockwise moves the selection to the right. Counterclockwise moves the selection to the left. And the inner knob gives you individual letters or numerals which show up in the flashing spot. Turning the knob clockwise moves you through the alphabet and numerals in the normal sense. Counterclockwise gives the reverse. Be sure that the inner knob is pushed in when you're doing this, or the computer will start trying to anticipate your choices. If the inner knob is pulled out when you turn it, the display will start filling in all the blanks with the next item from the database that is in alphabetical sequence. The display item being changed with the inner knob wraps around, meaning when you get to the end, it just starts the sequence over again. And be aware that there's one blank spot between the 9 and the A. Finally, GPS uses language that differs a bit from what you've learned earlier. It says waypoints when it refers to what you've been calling checkpoints. Any known location is a waypoint. An airport, a VOR, an NDB, a specified latitude and longitude, and so forth. If it can be located on a navigation chart or you can put it there, it qualifies. Now, it also talks about legs in a way that you may or may not be familiar with. And don't get the wrong idea. We're talking about the leg that corresponds to a horizontal line on your flight log. It's the trip from one checkpoint, or in GPS language, waypoint, to another. So now that you've made the trip around the GPS, you're ready to have it take you on a trip. And while your newfound navigational abilities may not get a strait named after you like Magellan, you won't ever get lost looking for the shortcut to the Indies like Columbus.